So this is building real-time data and web applications with Node.js. Just have to do the brief safe harbor. Don't make any purchasing decisions based on what I say here today. Don't think anyone would have. All right, so here's the overview of what we want to do today. We're going to start by talking a little bit about how we got here, then kind of where we're at today, what the landscape looks like, and then mixing in the database. So what I usually like to do at this point is skip over to the demo where I have everybody pull out their cell phones and go to a website. And you can kind of see what that looks like here. My VM is just entirely freezing up on me for whatever reason. And I'm unable to get out on certain ports here. But the idea is that you would come to a certain web page which has a listing of cities. And this was a listing of cities that I found on some website, like the most livable cities. And is anybody here from Berlin? Or I'm sorry, Germany in general? Germany had like 5 different cities in the list. It was quite impressive. But you know, it was just a list of cities, and the idea is that I would have you folks go here and just start voting for cities, and you can kind of see in real time how the votes are going. And what I do, I come over here to this dashboard page, and I kind of look at 2 different numbers. So one is the total number of votes that is getting submitted. And this number, you can kind of see it's incrementing as votes come in, right? It's 1 increment per vote. But then I have this other number here, updates pushed. And this is a really important number that is always much lower than this other number. And I just ask folks to make a note of that, as I'll come back to it later. So I apologize I couldn't get the demo working. But let's just move on. So really quick, I do want to get a sense of who we have in the room. Any JavaScript developers here? Wow, quite a few. All right. How about Node.js developers? All right, about half of that number. Cool. And of the Node.js developers, has anyone been doing some real-time stuff? Nice. All right, thank you. So let's start by talking about how we got here. So we're in 2017, right? It was 1997, 20 years ago, that HTTP became a thing. Prior to that, didn't exist. And when it first came out, it was a simple request response protocol. It actually still is. And so the way that that would work, the web browser issues some HTTP request to the server, and the web server then generates an HTTP response and sends that back out. And when you think about the early days of the web, you typically had something like Apache running for the web server, and so it was just static file reads and really simple to conceptualize. But then we realized we could do better, and we could involve a database in the mix. And so the way that would work, the web browser would still issue the same HTTP request to the web server, but then the web server would issue a driver request, usually over to the database, get some kind of data, and then the web server would use that data to generate some kind of dynamic web page, and it would send the HTTP response out back to the client. Now, some of you are probably thinking, actually, Dan, we do more complex work at our company, and so we do transactions. Our traffic looks a bit more like this. And you know what? Actually, when I think about it, we're sharding our database because we're a global company. And in our mid-tier, we're scaling via memory and CPU utilization. And we're doing all this work because we got a whole lot of users. And so our traffic is looking a bit more like this. This is kind of the reality that a lot of folks in the room are dealing with today, and I get that. But for this talk, we'll keep it simple. Just keep in mind everything I'm going to talk about does scale up to that with just a few more lines of code. All right, so at this point, once the web service responded, in a way, the browser over here kind of has a cache of the data that's in the database, right? And you think, okay, it's kind of in sync at this point. But you know what's going to happen, right? Somebody's going to come in, they're going to make an update to the data in the database, and so now the browser is kind of a stale cache, if you will. And so the question is, if you have the need, how could you actually get the update to the data all the way back out to the browser? Now, for the longest time, most databases have had the ability to communicate from the database to the web server. And so they could let the web server know that there's been a change of the data. But what we haven't been able to do is send something from the web server back out to the browser. That was impossible, and it was for really good reasons related to security. It'd be kind of scary if just random web servers could tunnel in to your browser. So that started the quest to simulate this kind of thing. Now raise your hand if you're guilty of any of these. Come on. I'm guilty of all of them. I've done each and every one of these. So the forever frame was kind of the original way to do this kind of thing. You would set up a hidden iframe in your web page, and you'd use the iframe to periodically check for new data on the database. And when you found new data, you would proxy it up to the parent frame and inject it into the DOM. That worked well. But then we got this thing called Ajax, and we like to give Microsoft and IE a real hard time, but it was actually Microsoft that came up with Ajax. And so Ajax was cool. We could set up something like an Ajax poll, so maybe using something like set interval, we would occasionally go to the web server and ask it if it's got any new data. That worked great, a lot cleaner than the forever frame, but the problem with it was this polling was really inefficient. Every poll was a round trip to the server, which, in terms of latency takes a little bit, but also you might then be issuing database requests for no reason. There's no change, but yet you're continually asking the database if there was a change, putting load when you don't need to. Long polling came along and solved a lot of that. This was a technique that I think Google really popularized through Gmail at first. And with long polling, the idea is that you're going to establish that connection to the mid-tier. Say, hey, got any more data? But you're not going to disconnect. You're going to sit there and wait. And then the web server would say, eventually when the database lets it know there's new data, it would say, I finally have new data. And it would respond to the initial request. You would update the DOM, and then you would establish another persistent connection for the long poll. So that worked well. It's kind of hard to scale. Google could do it. Maybe not a lot of other folks could. And then we got these HTML5 server sent events. And my guess is that not many people in this room actually ever heard of server sent events. And the reason for that brings us to where we're at today. We got some better technologies that kind of took over, and server sent events almost just went away. So we got some newer technologies. We got both WebSocket and WebRTC. And when you think about this talk, this is a talk on real-time data. Now WebRTC stands for real-time communication. You might think, obviously that's what I would use for putting together a kind of app like I was showing you. And the truth is, no, I ended up using WebSocket. But WebRTC is, in fact, a really cool technology. It's just best used for a different means. So the idea with WebRTC is that you're going to do a direct peer-to-peer connection. So rather than client to server, it's client to client. And it's really cool, especially if you're doing any kind of streaming audio or video, or arbitrary data like with video games, right? Because you're cutting out the middleman, the server. Hooking up clients directly is going to have the lowest latency. But for something like what I was trying to do, where we just have some votes kind of streaming into this app, and we want to see the latest and greatest data, who's having the most votes. Not really necessary. WebRTC is a little bit more complex than WebSocket because it requires a turn server. You can host your own. Most folks are going to use a third party. But I ended up going with WebSocket. So WebSocket's all about enabling that bidirectional communication that wasn't possible before. And one of the nice things about it is that it sort of tunnels into HTTP. So it works with all of our existing networks and browsers and whatnot. And so it'll first establish the HTTP or preferably HTTPS connection, and then upgrade that to WebSocket if available. And this is the perfect technology for what I needed. In addition, you can look at support, browser support, generally speaking. So this is from Can I Use, and if you have to support IE11, WebRTC isn't the best option for you. I've been watching a lot more green come on this chart over the last few months, but where I usually look is this number up here, the global support. So when that gets above 90, that's when I'm more comfortable using a particular technology. So WebRTC isn't quite there yet, but WebSocket, on the other hand, it's at 94% already. So this is a technology that you can feel more comfortable deploying, unless, of course, you have to support Opera Mini. So what does WebSocket look like? Well, here's a very high-level overview from MDN. And so the idea is that you're declaring a new variable, setting it equal to a new instance of the WebSocket class, and you just pass in the URL for the server. Once you have that instance, it's an event emitter, so you can set up listeners on open as well as message. So on open, that's when you're connected to the server. That'll be an event, and you can then use the socket to send data down to the server. Conversely, you can wait for messages, which will give an event, and you can then access the data property of the event. And that's like data coming into the browser from the server. So now that you have a better idea of what the WebSocket API looks like, I'd like you to promptly forget it. Because like a lot of APIs, it's really low level, meaning that it's good at what it does and it's super flexible, but it's a pain in the butt to use, practically speaking. So folks tend to build higher level APIs, and that's where you really want to work. So the go-to for this is Socket.io. It's been there for a while. It's still the go-to for me today. And when you think about Socket.io, you have to think and understand that there's really two parts to it. One part's going to be in the client in the browser, and the other part's going to be in the server with Node.js. So Socket.io out of the box supports some things that you would expect from such a framework, things like multiplexing and namespacing. If you're doing a chat app, you can put people in rooms. Also auto reconnect. So for example, if somebody's gotten connected, but then they get in the subway and they come out a little later and they get back on the internet, Socket.io is going to start to automatically pull and try to reconnect to the server and grab that latest and greatest data. So a lot of the things that you would normally have to implement on your own, you don't actually have to do. All right, so there's basically two different ways you could do this. Now, imagine you have a bunch of web browsers, and you can ensure, absolutely be sure, that all changes to data are going to go through your public API. Well, then you can do it like this. So the web browsers, when they first connect to your app, are going to establish a WebSocket connection. And once that's connected, they're going to persist. And then imagine some other one of the clients makes an API request, and they're going to change some data. What you can do in the mid-tier is sort of persist the state in the database as part of maybe some ORM you might be using. And once you get the commit or the confirmation that the change in fact went through, you basically have everything you need at that point to then broadcast out to the other web browsers that a change in fact did occur. So that works well, again, if everybody's going through your API. But there's another scenario that you might need to account for, and that's when folks can actually update the data on the back end, not going through your API. And the way that would work is kind of similar. So first, the browsers still need to establish a connection through your public API, and that'll persist. And then when they come in and make a change to data, the database needs to play a more active role at this point. So it's going to send out a signal to what I have here is listed as a database API. So note that it's behind the firewall. You can make sure you're controlling communications and not allowing anything else to come through on that wire, but it's just a signal to say, hey, there's been a change of some data. And that allows then the web server to, it could work either one of two ways. When that communication comes through, it could bring the payload, what changed with it. That would be a little less latency. Or it could just let the web server know a change has occurred, and then it could do its normal driver stuff to detect exactly what it was that changed. In either case, at that point, it has enough then to go ahead and broadcast out to the clients the change that occurred. So what I'll do now is just show you some of the code. I hope, anyway. I'm going to avoid the VM since that's been acting up. All right, so for me, this app is done in two different parts. And the part I want to focus on first is the client side, kind of the front end part. So this is an Oracle Jet-based application. And most of the source code goes in the source directory, and we have JavaScript here. Let me open this up just a bit. All right, so the main file is the file that gets everything kind of moving in a Jet application. But eventually, what I'm trying to bring in is this module I've created here. Jet uses require.js to define its modules. So that's what you're seeing right here. I'm defining a module for the app socket. And note that it's called app socket. It's important to understand that from the client side, the connection to the web server, you only need one WebSocket connection. You don't need different connections for different endpoints in your API. You just need the one. So you need kind of a singleton, if you will. And so that's why I create this single module on the app side for the one socket. And so I'm going to invoke the server side of socket.io here to get a single instance of socket.io. And then I can just return that out. So then any other module throughout the application that needs the WebSocket technology, it can just require in this module, and it's off to the races. It already has the connection. So the two pages we look at in this app the most, or the two views, there's the listing of cities which people interact with. And that's here. It's sort of defined here as an unordered list, and each list item is coming from an array of data. So the component that we use for this is an Oracle Jet list view, and the data source is listed here. It's SuperCity's data source. And then for each list item, you can see that there's a pointer here to the template, which is defined down here. So this is the template for list items. And then you can see I'm referencing various states, such as the number of votes for that particular city. And then there's the methods, such as if you click the vote button, what happens. So the view obviously is referring to some functionality that's defined elsewhere. It's defined here in the view model. And so note that the view model here is requiring in that app socket module. And I'm just renaming it here to IO for socket.io. And then what you're seeing here are just some lifecycle hooks. So handle activated means that the user's transitioned to this particular view. So when that happens, I just issue an AJAX request out to the API endpoint SuperCities, and I take the data that I get in, and I just I do a little sort function here, and then I can call the SuperCities data reset method and pass that data in. So as they transition, we're updating to the latest and greatest data. There's a little bit further down, you can see what happens with upvote. So again, just issuing a standard AJAX request on the endpoint for a particular city, and that would be a post in this case, so we're casting a vote. And down below here is where you see I'm finally using that IO module. So it's just IO on, and I'm setting up an event listener on the event cities.change. You can do this, there's many different ways that you can need to within an app. This is actually just a single string. It looks like I'm namespacing it, but it's just a simple string. And so when the change event occurs, the server is going to pass to me the latest and greatest data, so I can grab that off of the items array and then just invoke the change method and push that in. So of course, at that point in time, we have the latest and greatest data, and then the view automatically updates to reflect that change. So going back up and into the server-side app, this is just a typical Node.js application. So I had to install in the client side of socket.io, and of course here in the server side, we'll install a different one. So if you look in the package.json here, you'll see the socket.io that I'm using. And of course, everything here starts with index. So I'm bringing in things like the Oracle Database Driver, I'm bringing in Express, but I'm also bringing in two different APIs here. And this is obviously one is going to be public facing, behind or outside to the firewall, and then the other is just going to be behind the firewall for the database specifically. And down here, just focusing on the public side so far, I end up just mounting the router at /API. It's this part here where I pass in to the database API, the HTTP server, that socket.io gets used. So I'll show you that very briefly. So inside the database API, I'm bringing in socket.io. And again, just a single instance is all I need to handle all the connections to the web server. So when a change comes in, once I have that, I can use it to emit changes. And here you're seeing I'm emitting that event and then just sending data in the form of body here. So that's basically what's happening in this area. All right. So I mentioned if you're working in an environment where you can guarantee all changes of data come through your API, then you don't need to worry about the database so much. You can handle it all from the middle tier. But if that's not the case, and it often isn't the case, then you'll have to involve the database. So I'll touch a little bit on how that works. So just about any database you're going to work with is going to have two things. I work with Oracle database, but you'll find oftentimes equivalents or corollaries in other systems. But you're going to need some means of events and some means of communication when the events occur. So oftentimes when we think about databases, the first thing we think about is a trigger, right? So yeah, you could use a trigger. Oracle has two main types of triggers, both DML and system triggers. So when DML occurs, it's like insert, update, delete, something like that. Okay, cool, that's what's happening here, right? We're inserting a new vote into the votes table. So that could work. And the way a trigger like that might look is something like this. I'm creating the trigger, just give it a name, and then after insert on our votes table for each row, so it's a row level trigger, and then begin and end. And I'm leaving this kind of blank. We'll talk about the communication side of things second, but let's just focus on the events portion for now. So this could work, but it would be a really bad idea. Can anybody guess why? So we always talk about how I/O can be slow, right? And there's a famous image that's gone around for a number of years where it shows the latency for various forms of I/O, starting with like L1 and L2 cache on a CPU, going then down to RAM. And when you go from RAM to disk, there's like this giant jump. Everyone knows disk is slow, right? Well, what's slower than disk? Network. And the jump across the network is just insane, even compared to disk. So what you would be doing with a trigger like this is essentially tying a disk write to a network call, and you would just bring your database to a crawl. So this would not scale. It's a terrible idea. Don't do that. All right, the next thing I could look at in Oracle is called Scheduler. Scheduler is a really robust scheduling tool available in Oracle. And what you're seeing right here is the PL SQL API. So I can create a job. And in this case, the type is just a PL SQL block. And it's just a random block I'm sending in begin, do whatever, and end. And right here, you're seeing a start date. And below that, the repeat interval. This is like a calendaring syntax that can be parsed. It's super flexible. You can set things up to run daily, weekly, every other week, and that kind of stuff. But one of the neat things about Scheduler is that you don't actually have to set up a job that is running periodically. You can set up a job that allows you to call it when you want to call it. And why that's important is that it's almost like working asynchronously then, right? Because you can invoke it, it's going to spawn, or actually use a process from a pool of processes ready to do the work. It's going to do it using one of those. So you can actually combine both the trigger with Scheduler. And the way that would work, imagine for the notification piece, you create a procedure, a stored procedure called notify Node.js. And then inside your trigger, what I need to change is make it autonomous transaction, which is just a transaction within a transaction. It's just necessary for me to use Scheduler within a trigger. So then I can say, create a job, and it's going to call a stored procedure, and here it is. So now, when there's an insert, rather than wait for the network I/O to complete, for the insert to complete, it will complete immediately because it's going to do the network I/O using a separate process, an asynchronous process. So that could work. Maybe not the best choice. The next thing I looked at was something called advanced queuing within Oracle. And advanced queuing is cool, don't get me wrong. It can handle, it's really flexible. So you can do point-to-point, pub/sub, and it has this enqueue notification feature, which is really important. So imagine, if you have a queue and you want to know if there's new items in the queue, you have two options, right? You're either going to poll it, and we know polling's not efficient, or you need it to let you know when it has new data, right? And so that's what the enqueue notification's about. But if you've ever really seen a queue, it's kind of a beast. There's a lot going on there, a lot of moving pieces, so it was overkill for what I was doing. And then I came across this really interesting feature I had never heard of after over 10 years working with Oracle Database called continuous query notification. And this is what it looks like. I was really shocked to see how this has been there forever. But in the beginning here, this is the PL SQL API. In the beginning here, what I'm doing is declaring a variable of type QC notifications registration info. And then I can initialize that and pass in some things like a stored procedure name. And this is actually a callback. Oracle's had callbacks for a very long time. There's quality of service flags and a few other parameters I won't get into. But then what I'm doing here is I'm starting a registration, and then I'm opening a cursor. And the cursor is just a select statement. Now, one thing I'm not doing here is executing the query. I'm simply opening the cursor, and you'll see just below, I'm closing the cursor. That's enough just to let Oracle know what the query is, and then what Oracle does once you've closed that, it's going to start looking at the result set of the query, and if a change occurs in the result set, it's then going to invoke this stored procedure on your behalf. So that's the one I ended up using in my app. As far as the communication side goes, for Oracle, for the longest time, we've had all kinds of ability to work with packages that allow us to get out across the network, TCP, HTTP, various mail protocols, and so on. I didn't use any of those. There's another one called Apex Web Service, and this is a PL SQL package that comes as a part of another feature of the database, but we get it for free. And the reason I use that is because in terms of Oracle Database, when you're making a REST request, they have all the APIs. They simplified that quite a bit. So the way that looks, now we're getting to the implementation of the communication side of things, right? So here's notify the server, and all it does is Apex Web Service, make REST request, and we just pass then the URL to the node server and then the method we want to use. So in this case, I'm not actually sending the data that changed. I could do that if I wanted. I'm letting the mid-tier kind of figure that out on its own. I'm simply letting the mid-tier know that a change has in fact occurred. All right, so I'll show you a little bit of that code. So the first thing I needed to do was create a user to hold the data. So this is just a very simple script to create a user. Don't hack me. Then grant a few things. You do need certain grants like change notification to be able to use this particular continuous query notification feature. And then another thing about Oracle is that over time it's kind of become hardened. So starting with 11, you can't just make random callouts to any web server you want. You actually have to have a DBA usually, kind of open up certain ACLs, and so that's what I'm doing here. Again, a bad practice, I'm just kind of giving God access to this user. So once that's done, then I go ahead and I install, this is from GitHub, there's a package called Logger. And Logger is just a standard logging API that is super simple but really performant for Oracle. Highly recommend everybody take advantage of that if you have to work with Oracle. Then I create the table to hold the cities as well as the votes. Insert all of the cities. And here's where you get to the registration info. And it's pretty simple, as you see. I just want to point out one thing here. You notice there's a lot of optional parameters for this particular API. And one of them is the grouping class time. And remember before, if you think back to the demo I showed you, I said that there were two important numbers. One was the total number of votes, and so that one's typically incrementing, one would think, once for every vote that's coming into the system. And there's another one, updates pushed, and that's really important. So what I end up doing is a form of grouping here, and it's nice that it's just built into here, but you can imagine that if changes are occurring to the database really, really fast, the database is going to be sending a lot of requests to the mid-tier. The mid-tier is going to have to come back to get latest and greatest data. It's just not going to scale very well. So what we're doing here is saying, you know, any changes that occur, the second one here is the value, any changes that occur over the span of a second, we're going to group those together and essentially treat them as one change. So the grouping here allows us to kind of scale this thing a lot better than would otherwise be possible. And finally, my REST request was a little bit more complex than it might be for you, simply because I was going out over HTTPS, and for that you need to configure a wallet with Oracle. Again, hardened by default, so it's going to ensure that the certificates are valid and that kind of stuff. I think that's, oh wait, there was one other thing. I'll skip that. If anybody does want to access the code, just let me know and I'll make it available to you. Cool, so I showed you the method that I used to connect you know, the PL SQL API for continuous query notification. One thing I'm hoping that lands in the near future is native driver support. So Node Oracle DB is the database driver for Node.js that connects to Oracle. And in the future, this goes back to the safe harbor slide, we may have an API that looks like this. So forget about PL SQL. We're just staying in JavaScript, staying in the mid-tier here in Node. So what we do is bring in the database, bring in socket.io, and we use the database to get a connection. And when we have the connection, this is what could be new. We would have a method, something along the lines of create subscription, and we pass in a callback. But rather than a PL SQL stored procedure, the callback here is just a function I've defined down below, JavaScript function. And so we have the same kinds of capabilities here in terms of grouping class. I'm grouping by time and just 1 second. And then we can register a query. Once we have the subscription, we can use that to register a query. And so now it's going to start to listen for changes to occur on the data set. And when the change has occurred, all I need to do is get a connection from the connection pool, run my queries, do whatever I need to do to get the latest and greatest data, and then I can use socket.io to emit out the event as well as the rows that changed. Hopefully we'll see that land in the near future. So when I first talked about that number, like that's not incrementing, right? Total votes pushed. Some folks said that's kind of like a debounce. So I made this slide to just kind of talk about that very briefly. It's not exactly like a debounce, because a debounce, for the folks that aren't familiar with it, it's in JavaScript a technique where, let's say we have an input and you're trying to do some kind of autocomplete. So the user starts typing, and what you want to do with a debounce is for every key press, you want to make sure that you're not going and firing off an AJAX request, because the very next key press may invalidate that. So what you're saying is, you know what, as the events are coming in, go ahead and wait until you have at least X number of milliseconds in between the events, and then fire off that event. So in this case, I'm listening for click events on the window, and all we need to do is clear a timeout and then set a new one for like 3 seconds or whatever it is you want to do, and then after that number of seconds, you'll get one event that goes through. What we're doing with grouping is a bit more complex. So in the beginning, it looks similar. We're just adding a handler on the event, and then all we do is now record a group start. So just date.now on the very first one, and we can start recording the events. But what we need to do in terms of the grouping is something more like set an interval. And this interval over which we're going to check to see if anything has happened. So if there's events and the date is greater than whatever our grouping number is. So here I'm grouping all events in the span of 2 seconds down to 1. And then my poll interview is 1/10 of a second. So this is kind of what it would look like for grouping. And if the database you're using doesn't support grouping out of the box, you're going to need to implement something like this manually so that you can scale it. It's just not going to scale if you're doing one request per change. All right, so that's all I have. I do have like a slide here with some next steps. So if anybody's interested in kind of learning about any of the technologies across the various tiers, I'll provide these links and you can go learn about them. Feel free to fire off questions to me via email or Twitter. I'd be happy to answer them. Are there any questions? Okay. Well, thank you very much.